Today's lesson is 8.4 the binomial theorem. Now the binomial theorem has to do with the expansion of x plus y to the nth power. There's a pattern to this that makes it very easy to find things such as x plus y to the fifth. Or, an example would be 2x minus 3y to the fifth. So revealing what I show you so far here. Here's what we got. X plus y to the 0 is 1. X plus y to the 1 is x plus y. X plus y squared is x squared plus 2xy plus y squared, and so on. Right, you can kind of see the values there. Now, where's the pattern per se right now? So some commonalities I want you to look at for now is let's look at some of these higher powered ones here. So x to the 5 plus 5x to the 4, so on, right? So looking at the powers, right, we start with 1. All these have 1, right, because x times x times x times x times x. That first term is all the x's, and there's just one of them, right? Same thing with the y times y times y times y times y. But why do the numbers increase? Well, starting here, x plus y times x plus y, well, outer and inners are going to match. 1xy plus 1yx. Oh, we have 2 of them. And then the more you go out, you'll realize, oh, then we got 3 and 3. And so there is a pattern to that I will show you in a moment, but I do want to emphasize that we have x to the 5th, then we have x to the 4, y to the 1, x to the 3rd, y squared, right? And so x's are counting down by 1, while y's are counting up. Y to the 0, y to the 1, y squared, y3, y4, y5. And each set seems to add equal the general power here. 5, 4 plus 1 is 5, 3 plus 2 is 5, and so on. Where's the pattern? It is Pascal's triangle. If you've heard of this, great, you've got a head start. So, kind of cutting out what we have so far. In general, usually they're connected by lines, like they're going further out, because this is x plus y to the 0, x plus y to the 1 is 1x plus 1y. And then the next number is the diagonals. You add the diagonals above it. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. And then they spread out. So that pattern continues. Right? So we start with a 1, then 1, 1. 1 plus 1 is 2. 1 goes out, 1 goes out. 1 goes out. 1 plus 2 is 3. 2 plus 1 is 3. 1 goes out. 1 goes out. 1 plus 3. 3 plus 3. 3 plus 1. And so on. And the numbers get quite large. Now, how are these related? These are the coefficients of x plus y cubed is 1x cubed plus 3x squared y plus 3xy squared plus y cubed, right? So it is the pattern as well as the coefficients is what these are. Now, more importantly, we can also use our combinations. So, one more time, just showing you 1x cubed y is the same as 3 choose 0 for x cubed. 3 is 3 choose 1, right? And where did that 0 come from? The y power, the second term power. So 0, 3 choose 1. Well, we had 1y. 3 choose 2, 2y. 3 choose 3. We can also use those little parentheses for them, and you'll see that in a moment in the vocab. But first, find the following. 4 choose 2. You can technically go back and let's find row 4. 4 choose 2. 0, 1, 2. 4 choose 2 is 6. And it's got that in common. Others would say just use that calculator. Pop up the Desmos calculator. We do clear it out. We've got 4 function NC2. Now, just a note for these, for those who have been using these, you use NCR 4, comma, 2, close parentheses, and it calculates for you. Moving on. So 4 choose 2 is 6 if you didn't have a TI. Next, 11 choose 5 is 462. And 8 choose 3, that's what the symbol means, 25,872. Now, a little unfair, but we'll go over this in a second on why that's the symbol. And here it is. In the expansion, we've got this pattern, and the coefficient of x to the n minus r, y to the r, is n choose r. So based on y's power, n is the total, where you add these together to get your degree, and your symbol is big parentheses, n on top, r on bottom. This is often used in place of this to denote binomial coefficient, and it's also a little shorter. right? Between these two, I can make this a little bit smaller. Moving on. X minus 1 to the 6th. Expand and simplify. Now, generally speaking, there are two ways we can do this. I just showed you the Pascal's triangle. Why don't you just draw out a triangle to 6? You can do that. Sometimes that's helpful when you have something like this where it's 1x minus 1. Not very difficult. When we have different coefficients here, it gets a little more complicated. So this is the row 1, 6, 15, 20, 15, 6, 1, which is Pascal. Or we could do 6 choose 0 of the first term to the 6th, second term to the 0, plus 6 choose 1, because now we have one of these, of x to the 5th and negative 1 to the 1. So x's are counting down, the second term are counting up. 6 choose 2 of x to the 4, negative 1 squared. 6 choose 3, x cubed, negative 1 third, and so on. Now, you won't need to do both. Technically, 6 choose 0 is 1, 6 choose 1 is 6, 6 choose 2 is 15, 6 choose 3 is 20, and so on. 6 choose 5 is 6, 6 choose 6 is 1. Now, that doesn't also calculate the negative 1. So the negative 1 is literally just going to be nothing besides a change sign. So 0 negatives, still positive. 1 negative, this is going to be a negative sign. So as you notice, we got 1x to the 6th minus 6x to the 5th. Right, that's, plus 6x to the 5th times minus 1. As I simplify, what is this? What is this? And we're simplifying each time. That's just kind of showing that there's where the 1, 6, 15, 20, 15, 6, 1 come in. This one, and now simplifying with the minus 1, it just switches signs. Positive, negative, positive, negative, positive, negative, positive. And that's what happened. Because where we had an odd number of negative 1, it was negative. Odd number of negative signs is negative, right? Kind of just that simple logic. And there's our final answer. So how does it get harder? Here we go, the next two. 2x plus 3 to the 4th. So, our coefficients are 1, 4, 6, 4, 1. However, we have 2x to the 4th, not just x to the 4th. The 2 is included in that. So now we have another 2 to the 4th to deal with, right? And then when we move on to terms, well, let's say the next term, we'd have 4 times 2x cubed times 3, right? So then we have more numbers to deal with. So generally speaking with these, I recommend to write out whether you want to write these numbers in right away or not. I'm just going to do the 4 choose 0 for the next couple slides. But 4 choose 0, 2x to the 4th, plus 4 choose 1, 2x cubed, 3 to the 1, plus 4 choose 2, so on, 2x squared, 3 squared, right? Going down 1, so next is going to be 2x to the 1, 3 cubed, 2x to the 0, 3 to the 4th, and then simplifying, right? So what's 1 times 2 to the 4th times, right? And so on. So 2 to the 4th is 16, and now these will divide by 2. So the next one will be 8. Then, so 4 times 8. And then the 3's are increasing. So next one will be 8 divided by 4 is 4. Sorry, 8 divided by 2 is 4. Then 4 divided by 2 is 2. And then we're all the way done with those 2's. Well, the 3 goes the other way. 0, 3, 1, 3. 3 squared is 9. Times 3 again is 27. Times 3 again is 81. And then simplify. It's a lot of writing, but it is a lot of work. 16x to the 4th plus 96x cubed plus 216x squared plus 216x, yep, because these happen to match as the 6 goes down and the 3 increases. Divide by 2, this times 3, cancels out what the 6 did there. We got 81, and that is that one. And then the most advanced at this point is 2x minus 3y to the 5th, because we've got a negative sign to keep track of now, but the same idea. Here's our Pascal's. Pascal doesn't do the whole thing for you, though. You can't just say, oh, here's the answer, because we still need to deal with the negative 3's, the 2's, right? And the x's and the y's. So try it on your own if you're feeling comfortable. If not, take care of notes here. 1, 2x to the 5th, plus 5, 2x to the 4th, minus 3y to the 1, plus 10, 2x to the 3rd, negative 3y to the 2nd, plus 10, 2x to the 2nd, negative 3y to the 3rd, plus 5, 2x to the 1, negative 3y to the 4, plus 1, so negative 3y to the 6. And simplifying each of those, 32x to the 5th, plus 5 times 16x to the 4th, times minus 3, plus 10 times 8x cubed, plus times 9, and so on. Then multiplying, we got 32x to the 5th, plus 80x to the 4th, sorry, minus 240, forgot the minus 3, minus 240, x to the 4th y, plus 720 x cubed y, minus 1080 x squared y cubed, plus 810 xy to the 4th, minus 243 y to the 5th. And that's that. Now, what if we could just focus maybe on one term at a time? So that's what's coming up. Find the coefficient of 2x squared plus 3y to the 11th. Now, remember, what does the terms, right? Like, how do we know which choose it is? It is based on the y term. So when they say, oh, here's this, these powers don't add to 11 because of the square, right? So it's thrown off. So we want to rely on the y's, right? So we have 11 choose what? Well, y is the 7th. Something a little bit thicker than I wanted, right? Y is the 7th. So this is going to be 11 choose 7. Now, right, because it's choose 7, we're going to have y to the 7th, so 3y to the 7th, and then there's 4 left over for 2x squared. So 2x squared to the 4th, 3y to the 7th, because these values need to add equal 11. Not necessarily the powers because of the x squared throwing that off. So 11 choose 7 times 2 to the 4th times 3 to the 7th gives you a whopping 11,547,360 x8 y to the 7th. One last one. 2x minus 4y to the 7th. And again, using y as your guide. Up, we got second power there, so it's going to be 7. Where does the 7 come from? Right here. 7, choose 2, and then we're going to have 2x to the 5th, because these happen to not have an extra power here, but 2x to the 5th minus 4y to the 2nd. And then simplifying, right? 16 times 32 times 7 choose 2 gives us 10,752. And that wraps up today's lesson and this year's of lessons.